Okay, guys, this video is going to be over something that we call inelastic collisions. So we saw a couple examples of inelastic collisions when we did our original collisions lab. But today I want to talk about how we can do some calculations using inelastic collisions. So for inelastic collisions, essentially what's happening is this is going to be when two things collide and stick together. And I know, ooh, look at, ooh, stick together. All right, now I know that it seems like there's probably not a lot of times when this happens, but it's actually more common than you think. And so a really good example, since I know some of you guys like to skateboard, so imagine that you've got two things. So one thing is a skateboard, okay? And the other thing is you. Let's move this down a little bit. Okay, so imagine that you're running. So I have two things. I've got you and I've got a skateboard. And so if you're running and you're moving along and suddenly you jump onto the skateboard, well, now all of a sudden what's going to happen is that the original two things are now going to move as one, okay? So what I did is I went from having two things moving with their own mass and their own velocity to one thing moving together. So this would be a really good example of an inelastic collision. It would be my skateboarder example. And so there's a really specific way to calculate this because our rules about momentum still apply. So the momentum before is equal to the momentum after. So let's make a note here. So this is going to be how to calculate some problems that involve inelastic collisions. So we have to remember that momentum before is still equal to the momentum after. Now, this is going to look a little bit different because before we were doing calculations where there were two objects before and two objects after. Now there's going to be two objects before and only one object after, okay? So there's two objects before the collision and there's only one object after the collision. So like if we think about that person in the skater, we think about the person on the skateboard as one single object because it's moving together. And so what we're going to end up with is we're going to end up with something like mass times velocity plus mass times velocity because we want to find out the total momentum of that system. But over here, it's just going to be mass times velocity. But the thing that's important is this mass is just going to be the sum of the other two masses. Oops. There we go. So all I'm doing is I'm adding together this mass and this mass to make my new mass. So let's do a quick example problem, and I think this will make sense. So, example. Okay, so let's think about two toy cars. Okay, so let me draw a little toy car, use my amazing art skills. Man, what a toy car. And I said there's two toy cars, so let's put another one over here. Okay, so the first toy car is moving. The second toy car is sitting still. And let's go ahead and give them some masses too. So this toy car is 0.5 kilograms. That's 0.5. And we'll say that, let's do this actually. Let's make that a little bit bigger. I'll make that a little bit bigger. Okay, so that's 0.5 kilograms, and this is going to be 0.8 kilograms. Now, what's going to happen is that this car is going to move along. It's going to hit this car. Oops. And then suddenly, they're going to move together as one. Okay? So let's try and keep that in mind as we do this. Now, we have to do some velocities here too. So my velocity for this car is going to be 2 meters per second. And since this one's sitting still, it's going to be 0 meters per second. All right, so let's write this out. So I know that I want to have, and we'll call this car A and call this car B. And so I want to have the momentum of car A plus the momentum of car B. So this is going to be my momentum of the system before I start. So what I'm going to do is I'm going to have mass times velocity plus mass times velocity. Well, my first mass is 0.5. So I've got 0.5 times my velocity of 2 plus my second mass is 0.8. And my second velocity is 0. That came from there. Okay. And that's gonna be equal to the mass times velocity of the two cars moving together. And so my mass, I know that I can just take this mass and add them together. So I'm just going to have 0, whoops, oh no, you go away, oh, you go away. So I'm going to have 0.5 plus 0.8 multiplied times the velocity. So let's go ahead and do some of this. So I know that 0.5 times 2 is just going to be 1. And that 0.8 times 0 is just going to be 0. So I'm going to end up with, well, actually, I can, and then 0.5 plus 0.8 is just going to be 1.3. So let's do this. Slide this down a little bit. And I know that this is going to be, these two added together makes 1.3 V. So 1 plus 0 is just 1. So now I've got 1 equals 1.3 times velocity. I'm going to divide both sides by 1.3. And I'm going to end up with my new velocity is 0.77, 0.77 meters per second. And so what that means is, if we go back up to the top, okay, that means that my two cars, so this car, when it goes and it hits that car, then the two cars together are going to keep moving with a velocity of 0.77 meters per second. Okay, try a couple on your own.